We have a big test coming up. We'd like to do really well on this one. So, has anybody found something in the review so far? Some of you have been doing some review. And I just noticed have I told you why everything says period 5 and I love them and they have hearts and everything? That's for 5 years when I was administrator, I only taught period 5. I taught one class a day. And so everything said I love period 5 because that was the only period I taught. So I don't want you to get a complex. I don't love them more than you. It's just that's the only period I had for a long time. So when I'm reusing stuff, it all says period 5. Okay, you weren't concerned about it. Where's your school shirt?
Non-existent.
I'll have to do a check one. Who had a question about something? Yes, Vincent.
7 on the page right after the graphs.
Okay, this is not a sign.
Oh, it's not.
No, it's not one of the review sheets, so it's not a sign, but it's got some vocabulary in it. So let's look at number 8. Okay, what shape is this? This is an absolute value, but it's moved. It's not, this is where it's supposed to be. This one is not there. Where is this one? Left 2, up 3, perfect. So it looks like this, right? Now, what's the question? Name the intervals on which it's increasing or decreasing. So what does increasing mean? Hand goes up as we draw it. So that starts here, right? Which is what x value? -2. And goes forever, right? So there's the interval on which it is increasing. Now what does decreasing mean? Pencil goes down, left to right. Pencil goes down. So what's the interval on which it's decreasing?
Negative
Negative infinity to -2. Yep, that's it.
To -2.
Remember, we're moving left and right, so we're doing x values. So does that answer your question?
Yeah, thank you.
All right, has anybody actually begun the review sheets themselves and have a question about something? Victoria?
Number 2A.
2A. Find the, wait a minute. The function is 3x plus 2. Okay, that has no asymptotes. Because how do we get asymptotes? Denominator equals 0 is vertical, and then horizontal is where we still have a fraction, right? But we're comparing this way. So if you don't have a denominator, you're not going to have asymptotes.
Okay, I was just making sure because.
Yeah, it's a trick question. And what about holes? Can this problem have any holes? No, because the only way you can have holes is if what?
Part of the numerator, part of the denominator cancel out.
Something cancels. And if you don't have a denominator, nothing's going to cancel, right? So this has nothing. What kind of function is A? That's a version of the identity. That's a line, right? That's a line.
2E.
2E. Now 2E may have stuff because it's got a denominator. So is that 2x squared plus 6x over 3x squared minus 27? Did I copy that right?
Yeah.
Okay, So if I'm going to figure out where my asymptotes and holes are,
Gotta reduce.
I gotta factor it, yeah. So let's see, in the top I can take out a 2x and be left with x plus 3. And in the bottom, I can take out a 3 and then factor that. Uh-oh. We have a cancellation. So the problem reduces to this. Now, the fact that we had a cancellation means what?
There's a hole.
There's a hole. The hole is a point. The x-coordinate of the point is -3. Right? What's the y-coordinate?
Plug -3.
Plug -3 in right here, so I'm going to get -6 over 3 times. Put in -3, -6. Is that 1/3? So I have a hole at 1/3. -3 times 1/3. Do I have a vertical asymptote and a horizontal asymptote? I do. Where is my vertical asymptote? X equals 3. Groupies, where do vertical asymptotes come from? Denominator equals 0. Wouldn't 3 make that 0? Okay. Let's look back at the original problem. Where's my horizontal asymptote? Y equals 2/3. Now it's going to be the dumbest points you miss if you don't write these as equations. You're going to miss half credit if you just put the numbers. Make sure it's x equals for the vertical, y equals for the horizontal. You're not going to get those confused. Vertical lines cross which axis? Whatever axis they cross, that's the letter they are. So if you're a vertical line, you're x equals. All right, who else? Bailey?
3B.
Have you tried 3B?
Yeah.
Okay.
I got everything except for the middle point.
Okay, so 3B says so that top one is just our good friend, the absolute value, right? So I'll apply a couple points, make sure I get the right shape here. So there it is. There's the top one. That's our absolute value function. But I don't want the whole thing. I only want the part less than -2. So I'll erase all of this. Everybody okay with that? Now I'm going to go ahead and do the bottom part because she said she had that too. So let's see that. What shape is that? Parabola. I'll go ahead and plot my points so I get a good shape. There it is. But again, I don't want the whole thing. I only want the part that's greater than -2. So I'm going to erase this part. It's going to start right here. Now what's the middle one say? The middle one says y equals x plus 1. Now that would be a line, right? But I'm not even going to bother graphing it because it doesn't, what does it say? X has to be -2. Well, that's only one point. That's one x value. So if x is -2, what is the y value going to have to be? -1. So I'm going to plot the point -2, -1. let's go ahead and talk about domain and range here. What's the domain of this function? All the numbers. And what's the range? Be careful. Jamie?
I had a question.
Okay, we'll do it in a second. What's the range for Teresa? Okay, because this is the point -2, -1. So her first instinct is y is greater than or equal to -1. Does anybody see a problem with that? It's a very good first instinct, but there's something not quite right about it. Grace?
You can't, like, from -1 to 0, you don't.
Exactly. There's a gap in it right here, Teresa, see? In between here. So certainly we could say y is greater than or equal to 0, and then y equals -1. Yeah, that's how we would want to do that. Because there's a gap in that picture. Okay? Anybody else find something you had a question about, or can think of something you had a question about? Victoria?
Number 4, no, number 5.
5, which one?
5E.
E?
Yeah.
5E, that is the notation for composition. So I am simply going to build the composition G of f of x. And then talk about domain and range. All right, so f is 2 over x and G is 2x squared. All right, so what does this mean?
This is x goes over.
F of x gets plugged into G. So f of x is 2 over x. So I'm going to plug 2 over x into G. So won't that be 2 times 2 over x squared? Because we are plugging this in here. So that would be 2 times 4 over x squared, or 8 over x squared. Now we want the domain and range. Tell me about the domain.
All reals.
Ooh, watch it. X can't equal 0, right? Okay, let's refresh our memories. This is huge. What are the rules for domain? What are the 2 things I look for? Fractions, and why do I look for fractions? Because the denominator can't be 0. Do I have a fraction?
Yeah.
Denominator can't be 0. Right? What's the other thing I look for with domain? Square roots. Because why?
Can't be.
Whatever's under them has to be greater than or equal to 0. Can't be negative, right? I don't have that in this case, so I'm not worried about it. So my domain is everything except 0. Range is a little bit tricky. If we had our calculator, we could type this in and look at it. If we didn't have our calculator, could we still think about points? We're going to have an asymptote here, right? A vertical asymptote here. Does this thing have a horizontal asymptote?
Yeah, but
Where is it?
0,
At 0. Why?
because the denominator is bigger than the numerator.
Yes. So I have a horizontal asymptote at 0. When you start plugging x values in, what kind of numbers are you going to get? Positive. Aren't they always going to be positive? And what does it mean to be an asymptote? It's a line the curve approaches but doesn't intersect. So whatever this looks like, it's going to be positive and getting closer to 0. So what's your range? Y is greater than 0. Very, very good. And you did that without even drawing a picture. But you could have drawn a picture and gotten the same information. Good work. Anything else? Bailey,
Is removable discontinuity like when there's a hole?
that's a hole. That's the official name for a hole. Remember, discontinuities are anything that break the graph, anything that cause you to lift your pencil. There are two kinds. There are asymptotes, which completely split the picture into two pieces, and then there are holes, which are just little skips. Non-removable discontinuities are vertical asymptotes. Removables are holes, yeah. They're less severe. They're still gaps, but they're less severe. Jamie.
Number 2 on review number 2.
All right, let's look at review number 2 now. And number 2 says, find two functions that would give you this big function. All right, well, what's this big function doing? You give it a number, what happens?
Multiply by 3.
No, it doesn't multiply by 3. What does it do first? Squares. So we need a function that squares, and then next we're going to multiply by 3, and then we're going to subtract 1. So this function accomplishes 3 things. You only have 2 functions to get it all done, so something's going to have to do 2 of those, right? Doesn't matter which one. We talked about that yesterday. So what do you want, which one do I start with here? F. Start with F. F starts first. So whatever else F does, it's going to have to square, right? Because that's what has to come first. So if you just say, all right, F is going to square, then G has to do everything else, which is what? Multiply by 3 and subtract 1. Or you could let F do the first 2 things, which would be squaring and multiplying by 3, and then G would have to subtract 1. Either one of those, it doesn't matter. All right, anybody else? Uh-huh.
So we don't have to solve it after that?
What do you mean solve it? This is the composition. You're finding the 2 little functions that would yield that composition. If you built the composition, you better get this. That would be like a check you could do. But your job is to find the 2 little functions that give you that big function. Yesterday, did we finish the entire back page?
Yeah, pretty sure.
Yeah.
I mean, both sides of the back page?
Yeah.
We got through it all?
Yeah.
We skipped some? Well, I don't want to skip some.
I think we did it all.
Pretty sure we did it all.
We did all of it.
Yeah, all of them? So the whole back page we did, front and back. Okay, that's good. All right, so then we got our 2 review sheets. Yeah. All right, let's review a couple of things that we haven't spent much time on, and then I will let you review, do whatever review you need on your own there. Let's factor these cubes. All right, so take a second, see if you can factor those cubes.
Is
Is this on any review sheet?
No, I'm just making this up because I want to make sure we practice it. It was on some quiz. Okay, how'd you factor it? 2x minus 3, perfect.
4x squared minus 6x plus 3.
Oh, watch it, 4x squared plus 6x plus 9.
Plus 9.
Yep. Remember that this sign comes from the problem. So whatever the when you're doing cubes, so whatever the problem is, that's going to match it. This one will always be opposite of that, and that's always plus. Always plus. That came from squaring negative 3, so that's going to be plus. Okay? So if we had y cubed plus 8, that would be y plus 2, and then y squared minus 2y plus 4. Okay, Jamie?
Just to take the cube out. And make it 2x minus 3 cubed.
This, you mean?
Yeah.
Okay, that's a gigantic FOIL. That means 2x minus 3 times 2x minus 3
That's done.
times 2x minus 3. And if you FOIL all that out, you're going to get way more than 2 terms. Okay? Exponents don't factor out. All right, now get your calculators out. Let's try this. And I just did this real quickly, so I hope it works out. Okay. Alright, so here's the deal. I've given you 5 sets of points, and you know they could have real life meaning. I don't have time to make all that up. So there's just 5 points, and I want you to figure out what happens when you let x be 8. So what are you going to do? What's going to be your strategy? We're going to do. Yep, we're going to go to stat. Get your calculators out. Everybody needs to practice this. This isn't a group exercise on test day. And we're sketching, or we're scatter plotting these. And what's the purpose of the scatter plot? Well, to figure out if it's a line or a parabola, that's right, a line or a quadratic. So what do you think? It's your second line, right? So you know what you do next? Stat, calc, quadratic regression. Oh, shooty tooty.
Yeah.
I must have a mistake in one of my points somewhere, but that's okay. What's our equation? We can still get an equation. Let's round off.
Y equals 2.3x squared
2.3x squared.
plus negative 1.89x.
Negative, actually about 1.9 probably.
1.9, yeah, plus negative 2.3.
Negative 2.25. Now, how do I answer the question then?
Plug in 8 for x.
I put 8 right in here, right? So the answer to the question would be I got 129.75, would you?
Would you put the 8 in parentheses?
When you put it in,
Yeah.
I just put times, but you could, I think, those parentheses. Jamie?
Is it right to do second calc and then value?
Uh-huh. Yep. Once you have the equation, yep. Okay. All right. So, let's see. All right, you've got a little bit of time then, if you want to go ahead and start in on your review work. Tomorrow, we're going to do a little bit in the next section. So today is really your last review day.